Hi everyone, the Math Informant here. This is a continuation of a problem we saw earlier. In fact, if you go back, we saw the division of this top polynomial over this little bottom polynomial ended up giving us this answer, and we did it using long division. This time we're going to do it using synthetic division. So we should end up with the same result as we did right here. As we start the problem using synthetic division, the way this gets set up, there's a vertical bar that gets drawn, and then there's a horizontal bar. The top polynomial's coefficients, numbers out in front, appear here. You've got to be really careful. The thing that a lot of people screw up is they forget that every placeholder starting with the highest x should be there. So you need a number in front of an x cubed. You'll need a number to hold x squared's place. You'll need a number for the x. And then finally, there's this last number on the end. It's actually x to the 0, but it ends up just being a fixed constant at the very end. So you can write it in this format. As you start to fill these in, you'll go and see that x cubed was touching the 4, x squared was touching a -7, x was touching -11, and the number on the end was a +13. If you're missing something like an x squared, it still signifies that there's a placeholder. You just put a 0 in if it didn't appear in this one, in the top of your polynomial. On the outside, whatever's underneath dictates what goes on the outside. You ask, to get the bottom 4x plus 5 equal to 0, what would x end up being? Well, as you move this around, you get 4x equals -5. You divide both sides by that 4 and you get -5/4. This is exactly what we put on the outside of this vertical bar. So we're going to be putting in a -5/4 in this piece. So again, this idea of the bottom equaling 0 is what dictates the number that ends up right there. From here on out, it's fairly simple. You take this 4, you drop it straight down. Rewrite it down at the bottom. And now you're going to generate a new number over here. How do you generate that number? Well, what you're going to be doing is you're going to multiply the 4 that's down here at the bottom, this one, times the thing on the outside, that -5/4. Now, if you're not very good with fractions, you might double check this in a calculator, but what you'll end up getting is -5. That 4 will cancel with the 1 in the bottom. You'll get a 5, but it's negative because the fraction was negative. Then you add down, and you'd get -7. -5 gives us -12. Again, multiplication here is what dictates the next term. So the next piece that we're going to put in right here, the next number, -12 times a -5/4. This will end up giving us a positive, and 12 divided by 4 gives us 3 times that 5 will be 15. So every time you do this, these numbers come from taking the outer number and that bottom number, they multiply together, and they give us this number right here. That's how we're generating each one. Then we go straight down. 15 and -11 leads us to 4. This 4 now multiplies the -5/4, which will give us a -5. So just to confirm here, these two multiply together and generate that -5. Once we've got that -5, we go ahead, go down, and we end up getting 8. Each of these components surfaced in what we had before, but they're in a slightly different format. And this was a particularly tricky problem, which makes it a little more interesting. We're not done. We can't just pull all the numbers from here. The remainder is fine. 8 happens to be the remainder. You can pull it, but these other numbers right here, you can't. These aren't going to work by themselves. Why? In this particular problem, there was a 4 right here multiplying the x in the bottom of the fraction, which means each one of these numbers, except the remainder, needs to be divided by a 4 in order to get the correct quotient. All right, so what that's going to do, that's going to cause us to have the 4 that we've got here over 4. That's going to cause the -12 to get divided by 4. That's going to cause this 4 get divided by 4. These 4's in the bottom are because of this 4 right here. If we had had just x plus 5, we're done. We have the quotient for that. But because of this added 4 in front of the x, we have to do extra work. So if it's an x plus a number or an x minus a number, you stop right where we ended. But if you've got a number in front of the x, you need to divide down here each of the numbers that you got except the remainder. So as we divide these out, right, the 4 over that, the negative 12 over a 4, and this 4 over a 4, that will leave us with 1, negative 3, 1, and again, the remainder stays as 8. It is untouched. What do these represent? These each represent components that we already had before. If you start with a cube up here, x cubed, that leaves you with an x squared right there. The x squared then becomes the x, and where we once had an x, that leads us to something that will be our constant number on the end. What that's telling us is we have 1x squared, negative 3 x's plus a 1. So when we go to rewrite this, here's what we end up getting for the result. We'll have x squared, there was just 1x squared, minus 3x plus 1, and then at the end, that 8, it didn't get divided by a 4 because when we rewrite the original problem, we divide the 4x plus 5 at the end over that remainder of 8. So that 4 is still hanging on there. And if we go back, just to clarify again in case you missed it, the 1 and the x squared generated 1x squared here. The negative 3 and the x generated the negative 3x. And then the 1 is just this constant number on the end. And the 8, of course, is our remainder, and that appears in the top up here. And it gets divided by the 4x plus 5. If we jump back, check out the answer we had before. X squared minus 3x plus 1 plus 8 over that 4x plus 5. So the original polynomial was equal to this through long division. And as we can see, if we hop back over to the page we were just working on, we get the exact same result here. So hope this helps you guys out. Just understand how synthetic division works. Usually you hope that you just have an x plus or minus a number in the bottom. If you've got a number in front of that x, it takes one little extra step of division at the end before you rewrite that original fraction involving polynomials. Anyway, stay tuned for more. Subscribe if you hadn't to the channel. And as you guys have more questions, I'm curious to see what you guys are struggling with. So shoot your questions to themathinformant@gmail.com, and hopefully they'll appear here soon in YouTube. Take care and have a good one. Bye-bye.